We are continuing in the first section of Unit 9 in our Statistics OER course, and we are doing some examples of hypothesis tests for two sample means. So here we have another example. A study is done to determine if Company A retains its workers longer than Company B. Company A samples 15 workers, and their average time with the company is 5 years with a standard deviation of 1.2. And Company B samples 20 workers, and their average time with the company is 4.5 years with a standard deviation of 0.8. And the populations are normally distributed, and we want to do a hypothesis test to determine whether Company A retains its workers longer than Company B. So remember to clearly mark your population. We will call population 1 Company A employees, workers, and we will call population 2 Company B workers. The null hypothesis is always that there is no difference between the two populations. So the mean time that employees stay with Company A minus the mean time that employees stay with Company B is equal to 0. This is the same as saying that the mean in Company A equals the mean in Company B. But to check if Company A retains the workers longer, we want the mean in Company A to be greater than the mean in Company B. And in terms of a single variable, we want the value of the difference, mean sub A minus mean sub B, to be greater than 0. If you had chosen your population 1 to be Company B and your population A to be 2 to be Company A, then you would be doing a hypothesis test that the difference mean B minus mean A is less than 0. So alpha is 5%, and the observed difference will be the observed difference between the two averages. Remember that the one company has an average of 5 years and the other company has 4.5 years. So we are expecting to see in our technology x1 bar or xa bar minus xb bar to equal 0.5, a positive quantity. So let's see. I'm going to use Art of Stat. I'm going to use the app for confidence intervals and test comparing two groups. They compare two means, and I'm going to enter my own data. This is a significance test selection. It's not two-sided. I want it to be a greater than, and the null value for the difference to be equal to 0. And I see here that indeed the observed difference is 0.5. The standard error is 0.358. Remember, the formula is a little complicated. We will code it in our Excel spreadsheet later and have this done in Excel instead of by hand, or here in technology without even having to punch in anything. The test statistic T is 1.398 and the degrees of freedom is 23, which happens to be a whole number, surprisingly. So test statistic T is 1.398 and the degrees of freedom happens to be 23. The p-value comes out to be 0.0878. Which is greater than alpha, greater than the 5% significance level. So this is a right tail test. Make sure you sketch everything on your graph. The graph is a t-distribution, wider than a normal distribution, so make sure you give it some extra room. The label of your variable is t-scores of the difference between mean number of years in company A versus company B. So the difference of two means, these are the t-scores for those. And you have a test statistic of approximately 1.4, which is right here. This is a right tail test. Shade the right tail of this distribution. It has an area equal to the probability of getting this much or a more extreme difference between the two means of 8.78% or 0.0878. You can see it also here in ArtofStat being depicted in decimal form, not in percent form. And when the probability of you having this difference is greater than the probability of making an error of 5%, then this is not considered an unusual outcome, and we fail to reject the null hypothesis. And the conclusion is that at the 5% significance level, the sample data do not provide enough sufficient evidence to conclude that the average number of years employees stay at company A is greater than the average number of years they will stay in company B. Remember that we can do the confidence interval also as a method of determining the decision and conclusion of a hypothesis test. So here again, if we go in ArtofStat, we can select it to be a confidence interval. If you want to have a right tail test with a 5% probability of significance, with a 5% significance level, then you want the confidence interval that is a two-sided process to have 5% on the right tail and 5% on the left tail. So here you want to change this confidence level to be a 90% to show that you can have a 5% error on the right and a 5% error on the left. You will see that your point estimate is 0.5. This is exactly the observed difference that you found. And you can see that the standard error is listed as the same standard error that we originally had, the 0.358. And then you can see the margin of error to be a 0.6. And therefore you have an interval that goes 0.6 to the left and 0.6 to the right, and gives us a confidence interval for the difference of those two means. The mean time employees stay in company A and the mean time that employees stay in company B to be between negative 0.113 and 1.113. And you can see here that the value of the difference mu1 minus mu2 equal to 0 is actually in the interval. So we are 95% confident that the difference between those two mean population means could be 0, is a possible value, and therefore we fail to reject the null hypothesis, and we have insufficient evidence to support the alternative hypothesis.